So the next session is going to be discussing and continuing the conversation on energy provision for data centres, focusing on the risk associated and how operators can mitigate this risk. So please join me in welcoming our next set of panellists to the stage, moderated by Anamika Sawarkar, Sales Director, Europe and Africa, India at Trench Group.
Good afternoon, everyone. I hope you have had a very pleasant day until now. I welcome you all to the next session this afternoon on the topic of how to de-risk your energy provision. My name is Anamika Sawarkar. I am the Sales Director for the Trench Group for the region of Europe and Africa, and I will be your moderator for today. Why we are here today is because AI has changed the numbers. It has theoretically transformed the energy transmission industry. The demand from the data center industry is rising so sharply and much rapidly than what the grid planning planned just a few years ago. And we know that the grids are constrained, that the supply chain is constrained. From the Trench Group's perspective, we are an OEM for high voltage equipment like transformer bushings, wall bushings, reactors, and instrument transformers. So we sit at the physical interface of connecting the existing grids to the data centers. And there is a complete change in demand that we are seeing as well. And we also know that the regulatory frameworks that are supposed to govern these grid infrastructures were put in place decades ago, and they have not taken into account this new phenomenon that data center and AI computing is. So what we're going to talk about today is how to de-risk when we are talking about this new phenomenon in the market. And today we have a panel of 5 experts who are very closely observing and a part of this phenomenon from various points of view, right from policy making to lobbying, right up to the physical delivery chain. My job today is to make sure that we get to a practical end of this conversation. And I would request you that we briefly start with our introductions. So I would request you to, in 30 to 60 seconds, introduce yourselves, your companies, and if you could identify one major risk that you are observing right now.
So, Liam Newcomb, I'm responsible for energy strategy and product innovation at Greenscale Data Centers. We build large sites, typically for single tenants, 100 megawatts and up. Our main stressor at the moment is trying to negotiate between the customer load requirements and the TSOs all finding their way through understanding large load connections, fault ride through, and AI load impacts.
My name is Thierry Chamaillou. I work for Schneider Electric. I'm in charge of cloud and service provider for Europe, Middle East, and Africa. First thing first, bonjour, bienvenue en France. You're welcome here. I'll bounce back on what you just said. I think that the grid is currently, 1/3 of the grid is 50 years old. In less than 10 years, it's going to be 50 years old. AI and the technology that we embark grows much faster than that grid. So if we want to have some private investment to help that grid develop and strengthen up, we need to start sending some clear signal on the long run.
Yeah, good afternoon, everybody. Welcome to Cannes. Steve Bradley, JSM Group Services. We build substations, electricity substations for data centers and renewable developments. We also install large underground cable systems as well. So connections to the electricity networks is what we do, and fiber networks. So clearly we're into the world of constraints on electricity grids. It's well known. But we also want to talk about today about the physical constraints, not just the electricity constraints, but the physical nature and constraints of getting access to the grid systems.
Good afternoon, everybody. My name is Spencer Lamb. I'm the CEO for KO Data. KO Data is a UK-based developer and operator, so we acquire sites, design and build, and then in turn operate the data centers. The biggest challenge we're finding at the moment, certainly in the UK, is the uncertainty on timescales for the delivery of the power infrastructure to the sites, and that uncertainty is therefore delaying the business case and the sign-off from our shareholders and subsequent financiers. And without that certainty, it's very difficult to proceed forward. And this, I think, we're seeing across, obviously, ourselves, but also our competitors within the UK, and no doubt that's apparent across Europe as well.
Thank you. My name is Aad de Nelzen. I'm responsible for the power generation business at Solar Turbines. We build natural gas turbines for distributed power generation. And we've been doing that for a long time, only the last few years for data centers. When you asked, Annemieke, you asked us for one key element in the risk for power. I would say the difference in planning cycle and execution between the data center industry and the traditional power industry is so big that at the end of the day, for the operator, the biggest risk is of missing out, I would say.
Thank you so much, guys. Following up on what you said about cooperation, we see that the grids that we see in Europe mostly were traditionally made for the industrial load and the domestic load, and we know that those grids are now pretty much out of date in terms of the demand that we are seeing in the market. AI also did not exist in the material way that it does now when those frameworks were put into place. Liam, I want to start with you because you said that you are already engaging with multiple TSOs. If I may ask you, what do you see as the policy direction in the next 12 months? And a grid operator who truly understands what a data center looks like, how does that exist? Are any of the existing grid operators getting there?
Okay, so in fairness to the grid operators, I'm not sure the data center industry fully understands what the grid loads we're going to be connecting will look like in 3 to 5 years' time. I think our rate of change in the customer workloads, but also the rapid move into DC power systems, we're not really separable from an energy asset anymore. So where we're engaging with the TSOs, so we have a site in Ireland, which is on AirGrid, which has traditionally been seen as one of the policy leaders. They have 20 to 30% of their demand in data centers now. And they've identified that data centers are a critical threat to the Irish grid because of the way that UPS systems drop off and come back onto the grid. So there is a real threat of a blackout for Ireland. So they've really led the way with their large load connection policy, fault ride through, and active power recovery. The big challenge that we're having at the moment is we go back to our designers and our supply chain, and our supply chain are still trying to design the technical solutions to these changes from the TSOs. So what we really need to do is get together properly so that we can have system-level modeling of the power networks with our attached loads, with the intelligence that they're developing. And what I don't think most of the people in the power business have recognized yet is that the new infrastructure we're building for DC-powered loads is active. These are not UPSs that sit there in standby and wait. These things are actively modulating IT load in real time. They're actively managing subsynchronous oscillation, ramp rate, and other profile into the grid. And they're a couple of software changes away from doing fast frequency response, load ramp and load shedding, distributed energy response, etc. My concern is that the grid planners don't really understand the assets that are coming online, and yet we have incentives largely driven from the US and Chris White's policies to have data centers come and bring flexible demand and other services to the grid, and we're not entirely sure how to do that in a controllable and stable way.
It's a fair point, because what I hear is a certain lack of understanding by the traditional grid providers how to incorporate this very real phenomenon that is going to come to them and become an inseparable part of their energy assets. Spencer, there is something that I want to address to you, because this is very much connected to what Liam said right now. You've been very direct on the fact that the data center industry has been quite inconsistently and rather poorly lobbying to put forth to put the point across what it actually means, the data center phenomena, as compared to other traditional industries like the mining and the steel industries, who have been doing, first of all, doing it for decades and have dedicated teams doing that. According to you, what does a credible voice for the data center industry look like, and what do they need?
Thank you. Ultimately, it's a big question, thank you. We as an industry are evolving and growing very, very quickly. We have yet to consolidate our voice to each government or to each local authority, and we all do it in a disparate fashion. We need to be far more cohesive and collective in how we take the narrative to central governments as well as to local communities. And at the moment, we're doing it in a very disorganized way, which unfortunately conveys a situation where we're not controlling the narrative. And there's a wider view from how the data center industry is perceived. But unfortunately, what that means is that when we're trying to do things like get power to our sites, we're starting to come up against many objections. So it's important that we bring our thoughts together and we lobby each government that we work with as a single point rather than doing it disparately. At the moment, we don't do that. As mentioned, the steel industry does it, the mining industry does it. To be fair to us as an industry, we've only really been called an industry in the last 5 years. But because of the amount of power that we're seeking to acquire for our data centers now and into the future, we are a meaningful issue for the grid operators. And therefore, we need to engage with them in a way so they understand what we're doing, and we need to plan with them accordingly. We also need to do so at a political level within governments, because we don't do that at all today. So they can help us achieve the objectives. We explain to them the GDP increases that will be reflected from these data center investments and developments. And in doing so, we get their support. We then need to work with the local communities to ensure they understand the benefits that a data center can provide to their local community. We need to do far more than we're doing today. We cannot afford just to hire an agent to go and represent ourselves with the local people, with the local authorities. We need to be doing that ourselves. And I think we're very far away from it currently. And unfortunately, the more we carry on as we are, the worse it's going to be. We need to get together, we need to sort this out and go directly to these governments and to these local authorities to ensure we achieve what we need to achieve. And to do that, we need to stop doing what we're doing today, which is building data centers in locations that we've been doing so for the last 10 years that weren't planned in that fashion. 10 years ago, when the hyperscalers rocked up with their cloud demand, they dropped into three locations in the major markets across Europe. We've been building on that ever since. They are not fit for purpose for the future. We can't engineer ourselves out of these things. We continue to get the engineering teams to come up with more creative solutions, which are becoming more and more expensive. We're getting royally ripped off by landowners who are ransoming strips of land for us to cross with power connections. It's utter madness. So we need to work with governments to encourage the government to incentivize the users, i.e. the organizations that underpin data center investments, which are the customers, which are the hyperscalers and the neo clouds, to go to other parts of the country, and then we can come up with a definitive, architected data center plan. Thank you.
And thank you, Spencer. And I want to stay with you there on this topic of fundamentally rethinking where we are building the data centers. Because by all accounts, the current major clusters that we see in West London, Frankfurt, or even in Paris, they are physically and electrically exhausted. On all terms. But if you had to define what a genuine national data center plan looks like, if it were to be implemented, and I'm not talking about just a designated AI growth center zone, but a real policy lever with real commercial teeth.
Yeah, the first and foremost, what you need to do is to actually encourage organizations to go to that location. So the incentives need to be meaningful. In the UK, it's a very straightforward decision on the incentive, which is to make power less expensive in those areas that you want the data centers to go to, and it has to be meaningful. In the UK, our energy costs are extremely expensive. We're probably 4 times more expensive than some parts of Europe at the moment. So there are some levers that the government can incorporate into doing that because of the levies that are chucked on the commodity costs. So we could, as policy number one, or number one of the policy, reduce those costs materially by, say, 30, 40, 50%. And then you've got a plan that you can create by then allocating certain locations around the country that have availability of power today, but they have the access to the land and the ability to develop power into the future, and then align that with SMRs and the wind farms that are being developed across the nation. And that needs to be incorporated in a nationwide plan, but the fundamental point is that incentive, because without that incentive, that plan will not be executed, or is not executable, I should say.
Understood. Thank you so much. I would now want to go actually to the execution and the implementation part of this entire chain. The political and the policy dimension is one very, very important part of it, but the implementation or what happens once the approval is granted is equally important. And to take a slight detour at the Trench Group as an OEM of the high voltage equipment, there is a very sharp signal that we've been seeing in the last 2 and 3 years, is that we have hyperscalers, data center operators coming directly to an OEM like the Trench Group, essentially bypassing certain EPCs just to secure the manufacturing slots. Because the lead time and the supply chain is so constrained that after the approval has been gotten, which is in itself a multi-year process, it's practically impossible for the builders and the operators to wait yet another 18, 24, or 36 months for high voltage equipment to actually arrive at the substation, which is essentially physically connecting your grid to the data center. But what this tells us is the implementation part of it is, if not more, but as equally severe as the policy part of it as well. And that's where I want to put our focus on. And Stephen, this is where I want to come to you, because you work on the ground with the network operators and the statutory bodies as well. So it's a two-pronged question that I want to put to you, because you've already, let's say, highlighted some of the constraints before. On the electrical side, how do you think the data center operator should work with the network providers to use the existing capacity that they have in their network until the reinforcement is put into the place? And on the physical side of it, because we spoke about certain major clusters, we have a very big physical problem that the underground cables are getting congested close to these major clusters. So how should the data center developers coordinate amongst themselves to avoid certain issues like these?
Okay, thank you. Well, listening to Spencer and Liam there, it does make me think of a well-known phrase that we use in the UK, and that's about the fact that it's the first sign of madness to keep doing the same thing over and over again and expecting a different result. You know, it's bonkers where we're at now, and certainly Spencer's touched upon a point there where there's lots of capacity across the networks, you know, both in the UK and in Europe, existing capacity, particularly where we've decommissioned coal-fired power stations, gas power stations, etc. Much of that capacity and infrastructure is there now, and even around London, believe it or not, despite the headlines. So while we're in this state of madness, we've got to do something, because a lot of the policy changes, regulatory changes, etc., take a long time to come through, despite the lobbying that's required. So whilst we're in this state of madness, as I say, we've got to do something. And that's about trying to make use of that existing capacity that's there now, particularly on the electricity grids. So how do we do that? And Liam touched upon some innovative solutions that can be deployed, new technology that can be deployed, that the network operators need to open up to understand better, talk to data center operators who are doing a lot of work in this space to come together and make that happen. But believe it or not, there's some traditional approaches that can be deployed as well, and they're not new. But I hear the talk about ramped profile solutions, so connection offers that are given to data center operators. Clearly, they're given what they want. If an operator asks for 100 megawatts, they get a connection offer for 100 megawatts, but guess what? It's in 10 years' time. But a data center doesn't need 100 megawatts on day one, right? So what we should be doing is working with the network operators to understand what the profile of that data center take-up is going to be. Very simple. No one knows exactly how that's going to be taken up, but you can have a good guess. And work with the network operator to make use of some of that local existing capacity to deploy some of that power requirement in its early phases. And then the remainder of that power requirement can obviously come on stream when all of the reinforcement works have been taken place, maybe in 5 years, 6 years' time, etc. So it's quite a simple approach. It's something that we've been doing in this industry for decades, actually. It's not new. It's just about the network operators opening up, getting the engineers, the planning engineers, the teams to work with customers in a better way. And this is where, we talk about coordination. That can even be done at local network levels with each of the network operators, and stop sitting behind the regulation. And I know that's happening across Europe as well as in the UK. So some of that can be done in this state of madness that we currently find ourselves in. But also, it's not just about the electricity challenges, because we've got to get the physical kit deployed as well. So the substations can be built on the land that the data center developer or operators have bought. So that's the first thing, and that's a pretty controlled environment in many respects. But what's less controlled and is very haphazard right now, and we at JSM are doing our best to work with network operators and data center developers to coordinate, is about getting these underground cable systems built. So the pinch points clearly are at the existing substations, mostly, the grid supply points. And if we're not careful, the physical nature of getting access to these substations is going to be quickly used up. There's only certain routes in and out of these substations. And if we're not careful, if we don't do things in a coordinated way, and even with the new substations that are being built now, if we don't do things in a coordinated way, that space, that physical space, is going to be used up very quickly. And we're not going to maximise the opportunity or the capacity that these substations offer. So it's about designing a solution. And again, it's not innovative, it's just about working together, but getting as many ducts and cables, circuits, deployed in the best way. So we can maximise that space, that ground, those roads, accesses to the substations in the best way possible. Okay, and as I say, it's not simple. It's not difficult. Sorry, it's very simple. It's just about talking to the right people who've got the design teams to deploy those solutions.
Understood. It is indeed simple yet complex at the very same time. But I want to draw upon one of the topics that you said is using the existing infrastructure and then bridging the gap until when we have the full resources as we are planning to implement them. And this is when I want to come to you, Art, because solar turbines sits directly in between bridging and a long-term solution. So you said earlier that solar turbines, you sit on the power generation side of things, and traditionally you have supplied to the more traditional network providers or energy operators globally, and to the industry like the data centers now. From your perspective, how do you see the risk landscape evolving today?
Yeah, so risk in this industry is very multifaceted, right? We talk about permitting, we talk about emissions, we talk about environmental impact, we talk about the risk for data centers with their constituents and maybe the communities they build. And so there is so much to risk. But if we look at the mission-critical nature of the industry, let's focus on that for a second. That's where we have experience. We have decades of experience building distributed power generation for mission-critical operations in oil and gas, in power generation, and that's where we come from. And being part of Caterpillar, an organization where we produce reciprocating engines. We have solar turbines with our gas turbines. There are other technologies to provide solutions. So we think we are a meaningful partner in the discussion about how do we find solutions that secure these this mission-critical operations of a data center. For on-site generation, I think the number one challenge today, the big risk, is availability of power generation assets. That's a big risk. Make sure that you plan ahead, right? If you want, and it sounds a bit like an open door, but it's definitely the topic of discussion today and this week. The people we speak, it's always about, okay, how do we together plan ahead? Then planning ahead, it's not only about capacity, megawatts or gigawatt. It's also about how does the solution look like? Because the data center industry is extremely dynamic, and the solutions, the quality of power that need to be provided is very important too. It's completely different when we serve an AI learning data center or an inference center, right? Or it is completely different. We need different technologies to be combined on site to find that optimum solution for the specific case. Again, this demands that we plan ahead. And then, lastly, the environment around us is so dynamic as well that we need to plan for the future, because wildly just securing that power generation asset straight away for right now, for having that gigawatts or megawatts on the books, that doesn't do it alone. We also need to plan ahead. Environmental restrictions are changing. The role of your power plant that you put behind the meter will be different in 10 years from now. The grid situation will be completely different 10, 15 years from now. There will be way more renewables on the grid. The demand or the need for support to the grid will be way different. And all the capacity that we implement in the market needs to be useful capacity also in a future state. Is it in terms of emissions? Is it in terms of efficiency? Is it in terms of capabilities to support the grid? Start time, reaction time to grid variation play a meaningful role for the infrastructure in 10 to 15 years from now is very important too. Now, all these elements need to be taken into account when you make the decisions today and build a plan for the future.
Absolutely. But a lot of examples that you gave, Art, were initially thought as a stopgap solution or a bridge solution to, let's say, deter the grid delays. How do you ensure that these become smart, long-term investments and not stranded assets for the operators?
Yeah, well, that's a bit what I meant, right? And bridge, the discussion, like it's a bridge solution, I think it's almost behind us already. We had maybe 2 years ago when we spoke to our customers, they said we need this power generation on site because the utility, the utility power supply will be there in 2 or 3 or 4 years. That 2 or 3, 4 years is not anymore 2 or 3, 4 years, but is 10, 15 years. So we're not talking anymore so much about only bridging the utility. It's about building solutions that are there as soon as possible today and then are ready for the future. Now, ready for the future, I mentioned a few things, right? Making sure that it is equipment that can support the grid. If and when the grid eventually gets there. I think also efficiency continues to be an important element that is sometimes overseen when we want to realize those data centers and the power infrastructure so quickly. But if we are clever with the integration of power generation assets in the data center operation by leveraging the exhaust heat and producing cooling, building combined cycle and combine the remaining heat with the cooling needs of the data centers, then we can build a system that is holistically more efficient and built for the future.
Absolutely. So pulling this all in, I once again want to talk about how does it look like in practice having a genuinely de-risked energy provision for operators like yourselves. And Thierry, this is where I want to pull you in, because you from the digital infrastructure side and the energy management side have the visibility across Europe, Middle East, and Africa from the other perspective also. So I want to know from you, since Schneider Electric sits at the intersection of energy management and digital infrastructure, how do you see the operators, the network operators? Just like Art says, there's a queue, and the operators know that there's a queue which is on a waiting list for 3-4 years. How are the operators dealing with this pressure that they're seeing from the market right now? And on the other hand side, is there any risk that the data center operators are underestimating right now?
Thank you. So first question. You're right. We're dealing with a lot of operators, but Liam, allow me to share what we're doing together. So any operator will be facing that never-ending queue to get access to a permit, and after that, to get access to the power. So I mean, if you cannot change it, you need to get the best out of it. So we need to work on the downturn of the supply chain. We tend to work on defining what is actually going to be played up as a deployment and start integrating that logistics. We start integrating the manufacturing. When, for instance, Greenscale, not to name them, are actually putting some deployment and some assets, they're already thought with an AI-driven design, which is going to be helping some of the stabilization that you need to be having and providing to the grid operators. So then your discussion with the grid operator becomes a little bit different. You embed the add-on of what AI would be helping you in defining about disruption, upcoming disruption, load, peak, and so on and so forth, but also to stabilize in a way. Why? Because it's been said, you're never going to be seeing a data center from day one at 100% usage. However, the ramping up, the use, and the peak shaving is something that is actually apprehended. If you back that with some software that we use inside the house in Schneider, which is like to use those logarithm with alpha structure, for instance, where you can modulate which type of energy you're going to be pouring into your data center, be it like fossil or be it like renewables. It could be actually BESS. You actually decide, because the algorithm works back 15 minutes, 30 minutes, an hour on what has been actually the usage, extrapolate what it could be, and define for you the best energy source. Then you take that into that discussion with the DSOs. And you have a different type of discussions. Back to your point, Ad, and the discussion has to be, which you can actually decorrelate and then put it in front of the discussion that you have with the European Commission. I'll get there in a minute in the second part of your question. And then the discussion that you're having is that, yes, we want to be contributing to the grid stability, and we are not a consumer. We're a DC operator, and this is how we're coming. We're coming with a virtuous approach to how we can together manage that grid, right? And I really believe in that virtuous approach. It gives me a segue to answer your second question, which is the discussion that you need to be having with the European Commission. Why the European Commission? We tend to blame ourselves. You said it, Spencer. You said it, Stephen, about what we do as a data center community. If you have a look at the last 20 years, we've been by far the most efficient, industry. By far the most efficient. Considering the amount of megawatt, gigawatt that we've been using, the efficiency that we have pulled in there, we have definitely not been, killing the amount of energy. So the efficiency is paramount here. But when you talk to those people that are actually managing the grid, the one that I was talking into the introduction, that have actually been doing nothing in terms of investing on their grid, and which is 100% of their business, this is where it becomes very interesting. Why does it become very interesting? Very simple. You know, if you want to give priority to the land permission, and back to what you were saying, Spencer, if you can demonstrate that you have a virtuous aspect in your design, in your deployment, you know, that is going to help the stability of the grid and the better management and expectation, anticipation of where the grid is going to be, you should be getting the priority in return. That brings you to the Grid Act. So we've talked about the CAIDA a lot at the European Commission, but you have also to talk about the grid package. If you talk about the grid package, this is where the hard work that the DC operators are doing should be rewarded positively with that type of, you know, faster access to the grid.
Thank you so much. There is one last question that I want to pose to you, Liam, and then I see that there are some questions that have already trickled in. Because I want you to share that one example that you shared with us during our preparation session, and is that what happened in Germany when you connect with the TSOs. And I want to know from you, is that kind of a regulatory risk manageable? And I would want you to expand on what I'm talking about for the audience here. Or is that a genuine blocker to the combined investment model of the energy investor and the network operator?
Okay, so the German regulatory shift I mentioned is the German grid has moved a few times in the direction of applying grid fees to private wire or behind the meter assets. And there's currently, let's say, uncertainty where that will land. There is a valid public policy argument, and if you look at AirGrid, as pointed out by the second question, AirGrid have gone all in on that. I think the underpinning to it is we need to maintain our social license to operate. 10 years ago, if you got in a taxi from an airport to go to a data center, the taxi driver would say, data what? Now they have an opinion, and it's not necessarily good. We need to work on that. So data centers need to start making the contribution back into it. So I think the way to deal with regulators attempting to modify the regulation to drive our behavior is to offer a better outcome. I spent a lot of time on the EU Code of Conduct for data centers, and that was a pre-regulatory initiative. So what we're looking to do at Greenscale is use our data center load, which is a large energy customer, to drive and make economic again in areas renewables build out. We've seen horrible capture factors for wind and solar across much of Europe. A data center buying pay as produced at a fixed rate is almost perfect for a renewables producer. What we also do, though, is we make our generating capacity available as grid firming. Then we're not buying two sets of assets. So we deal with a supply chain problem and an economic problem in energy price at the same time. AirGrid are right there putting backup generation at the data center into the capacity market, so the TSO doesn't have to buy more capacity and put everybody's bill up because there's a data center in the room. So by deploying these as a combined asset, working with the grids, energy asset owner investors, and the data center build, and tailoring that to the local situation, I think that is how we get that social license to operate, but also our non-firm ramped connection, the other things we would be looking for from the TSOs. We need to offer a solution here and not just complain it's not working for us. That doesn't get you anywhere useful.
Understood. Thank you so much, Liam. And then with 5 minutes to go, I think we should switch to the two questions that we see on the screen. The first one being, should regulators mandate technology like superconducting cables instead of just outcomes? Should we unbundle grid nodes for open access to substations similar to Ofcom and BT? Or is the real constraint in outdated protection relay settings and load forecasts since 2015? I think this is a very technically loaded question, and you guys will have to help me understand it a little better, but any takers?
From England, so at least I know all the organisations. I would not mandate technology. We We did a little bit of that in the EU Code of Conduct. Those bits didn't age well. Mandating outcomes almost always works better than technology. Unbundling the grid nodes, I would say yes, in conjunction with the DSOs and TSOs. We need to let them plan and let us build a combined asset. And as for outdated relay settings and load forecasts, the TSOs all desperately need more real-time data about network capacity.
I only have one thing to add, because it is highly technical and beyond my technical capabilities. It's the second question in the first question. Should we unbundle grid nodes? To some extent, aren't we doing that with the IDNOs? In effect.
Correct.
So what we need to step up further than that. We need to go to the national grid and apply that same approach, and getting organisations in to provide a competitive environment, to do it cheaper, more and far quicker than it is done today by NESO and the national grid.
Stephen, you were going to add something?
Yeah, correct. That is something we absolutely need, and it's being asked for right now, is to get independent network operators transmission licenses. So that's something that's actively being worked upon. But I guess, you know, sadly, when we're just looking to regulation to make these changes, I think we're all going to be waiting a very long time. I come from that regulated background, and I could see how difficult it can be to get all of the network operators to agree on what changes need to be made, but B, listening to customers and quickly responding to what they want and need. Those things just don't happen quickly enough. So yeah, it's a combination of what we've talked about, but getting on and trying to make some of these changes within the context of the current regulations is where we need to be.
Yeah. Just maybe one point on what Liam said about, you know, on the first question on the need that the DSO on that real-time information. I think as well that's how they use, you know, how, you know, those actually that they forget to use the interoperability that AI would help them have. They're busy, you know, at regulatory level, you know, asking the TSOs to standardize on one thing, and the DSOs on another thing, and the DC operator on another thing. And they're just killing the ability that using AI to have that interoperability where you start pulling actually real-time information, which is actually speaking the same language between the DC operator, the TSOs, and the DSOs. So I think this is where, you know, we have to be lobbying and have a stronger voice in telling them what to write and what to stop writing.
Understood. Thank you so much. Moving on, and we have a question about AirGrid already requiring data centers to participate in grid services. The benefits are clear: better grid utilization, less build-out, lower costs. So what's blocking this from becoming standard practice across Europe? Commercial incentives, technical readiness, industry inertia. What needs to move first?
I think I'll probably take that one. The answer is it's likely to. ENTSO-E's most recent position paper asks for everything AirGrid have asked for, and reactive power and some other absorption, including AFRR services. What's blocking it is no one else has the same level of pain on the grid as Ireland yet, but I would expect a majority of it to roll out for political and commercial reasons. So design assuming that whole FRT and everything else is coming.
Yeah, I can just underline it. I want to say the same. This will be coming. When the pain gets big enough, Ireland walks ahead of that because they have this density of data centers on the grid. It will be coming to Europe as the pain grows.
Understood. In the benefit of time, I would quickly move to the third question, which is, should we be applying more pressure collectively in the UK amongst the data center industry on the NESO and the connections reform process and the long delays faced with modification applications on the network?
Do you want me to take that one?
Yeah, sorry, I can take that one if you want. We are lobbying NESO with other data center operators in the UK and have been doing so for some time. This has been corralled by Tech UK, so there is a common theme and a collective view and an agreed view, so it has some power and some weight and it is working. But I think we have to also be conscious of the fact that NESO is an organisation that is under pressure. It's been under pressure hugely from the previous government and current government's net zero ambition. So therefore that's created massive issue for them with all the renewable energy projects that have been chucked into the queue, the battery projects, et cetera, et cetera. And then the UK government announced 18 months ago the AI Growth Zone initiative, which unfortunately created a nonsense where you had any landowner across the country putting an application in for power to flip their land and make a cool, you know, double or treble on the deal of value to them. So unfortunately, I think they're under huge pressure and they don't have the bandwidth and the resources to do what we need them to do. But in my opinion, it has to come at a political level above them, so they instruct them. And I think that's, therefore, our responsibility to get the political instruction achieved. So ENISA is then told what to do, and then their resources are aligned accordingly. And at some point, we'll probably need to contribute to that in some fashion, more so than we are today.
Yeah, I can add to that, Spencer, as well. So connections reform, what worries me here is that took 2 years longer than was originally set out. So the last thing the data center industry needs is a 2-year delay, and it could be longer. But coupled with that is, as a UK government, it was fairly easy for them to prioritise energy need, i.e. energy supply, battery storage, you know, solar farms, etc. But it's a very different proposition to dictate prioritisation of demand requirements, okay? And that's not just in the data centre industry. We've got to bring in play, you know, residential developments, hospitals, education centres, you know. How do you prioritise demand? It's the market that dictates demand, generally speaking. So that's a big problem there for NESO to solve. But look, it's coming. I can see connections reform is coming in the data centre world. I don't think we can get away from that, just to, you know, to sort out the queuing issues and the delays. But there's stuff that can be done up front. You know, we shouldn't wait for the whole problem to be resolved, i.e. this 2-3 year delay. We can get on and start, as I said earlier, using some of that existing capacity, you know, some early stage prioritisation of actions could be deployed to allow the data centre to still breathe whilst that whole problem is being resolved.
Understood. The last 2 minutes, and apologies to the audience that we've overshot, but I think it is definitely worth it to circle back to our original question of de-risking the energy provision. In 30 seconds or less, if you guys could talk about what are the concrete steps the operators and the network providers can take within the next 6 months to de-risk the energy provision. I would like to start with you, Art.
It's a big problem for 30 seconds, right? But I would say if we all start planning ahead, so looking at the data center industry, the cycle time is way faster than the power industry cycle time and planning time. But we have to, and I don't think that's an advice we have to give, that's intrinsic in the data center industry. We go ahead fast and plan fast and execute fast. But plan with an eye to the future, involve the suppliers, the know-how centers in the power industry to make sure the design of your power plants are future-proof.
In the next 6 months, that's very short in the power and data center world, but my suggestion would be provide quickly a powerful incentive structure alongside a map of each market across Europe where there is availability of power, and allocate that incentive, powerful incentive to that, those geographies to encourage data center developer operators and our customers into those locations. And very quickly, you'll take the stress out of the current dynamic that we're dealing with today.
Yeah, and for me, it's just, you know, effectively moving on from what I've said earlier, it's just making use of that existing capacity. There's ways and means, you know, traditional approaches that we can get access to that existing power, and it can get some of these developments underway. As I say, it's unfortunately in our world, we're always trying to solve that whole problem. If we take it in manageable chunks, then I think there's a way forward.
I would say, yeah, along the line of planning ahead, I mean, you need to be elevating the debate with the authorities on how you can provide something which is resilient, efficient, sustainable on the long run, and prompt in return that you get favored for helping them manage the grid. So into the DBOM, unknown, very well known of data center, I would say, insert an S for simulation. Use software to preempt that, showcase what you're going to be doing, demonstrate what you're heading for, and take them through this.
Recognize you're in the energy business now as well as the data center business. Do the modeling, go to suitable locations, but partner up with or develop energy expertise for networks, make friends with your DSO or TSO, and actually understand what they need and bid them something that has benefit to their network. Go build something on a nice big renewable supply. South of France here, lots of solar and battery, plug it in, private wire. There are plenty of things we can do to step outside of the stress we're currently causing. But key thing, you're not just an energy consumer, you're in the energy business and you're in the supply and generation business and taking part on the grid now.
Thank you so much. And from an OEM perspective of the Trench Group, I would also like to summarize and add to what Art said in the beginning. There are a very few things that we've learned now are actually within your power or full control, and procuring your material and the power systems and the high voltage equipment that will make up your substation is within your grasp and plannable. So for the Trench Group, de-risking really looks like the operator securing the slots so that when the approval is through, your equipment is there right then and there where you need it. On that note, thank you so much to the panelists, to the audience as well. I hope there are some points that you are able to take away with you. Let us please continue the discussion, and I wish you a great rest of the day. Thank you.
Thank you.